All right, students. We are in Chapter 1 review, and today is the first day with the new microphone, so fingers crossed both it works and it sounds better than all of the other videos. Okay, here we go. So what we're going to do is I'm going to do all the odd ones for this Chapter 1 review, and you're going to do all the even ones. And the ones that I do, you will have similar ones on the test tomorrow. So if you don't understand any of them, make sure you watch it in the video. And if you still don't understand them, please ask, because these are very similar to the problems that are going to be on your test. All right. Simplify the expression. Write your answer using only positive exponents. All right. So we know that if it's a negative exponent, we have to move it to the opposite side of the fraction. So we'll start this one off. The 2 to the negative 3, that's going to go down and become a positive exponent of 3. X to 0, that's just 1, so I'll just put it. Y to the negative 4, that'll go up top to become positive. Now we know that anything times itself, anything times 1 is itself. So we have, this will be y to the 4th over 2 to the 3rd. 2 times 2 is 4 times 2 is 8. So we have y to the 4th over 8. All right, give number 2 a try. Number 3. 5 to the negative 6 times 5 to the 3rd. Well, we know if we're multiplying exponents, we subtract them. Negative 6 plus 3 is negative 3. So we have 5 to negative 3. Now, we can't write these with negative exponents. So what does this mean? Well, that means that it goes to the bottom side of the bottom of a fraction, to the denominator. And 5 to the 3rd. 5 times 5 is 25, times 5 is 125. So what I get is 1 over 125. All right, number 5. Now, this negative is attached to this whole thing, to everything inside the fraction. Inside the parentheses, excuse me. So, since it's a negative, the first thing I'm going to do is I'm going to flip it. 3a to the 3rd over 1. This is all to the 4th. Now, 1 on the denominator. 1 to the 4th power is 1 times 1 times 1 times 1, which is 1. So I actually don't need this anymore because it's just 1. Anything over 1 equals itself. So now what I have to do, though, is I have to distribute this 4 to the 3 and to the a. So what I get is 3 to the 4th a, and if I'm exponenting an exponent, we multiply. Remember, we multiply. So 3 to the 4th times a to the 12th. 3 to the 4th. 3 times 3, that's 9. 9 times 3 is 27. 27 times 3 is 81. So we get 81 a to the 12th. Okay. All right, any questions, stop the video or give me a call or ask me. Let me help you. All right, so we have negative, and then we have the 3rd root of 216. So what times what equals 316? So let's see what 4 times 4 times 4 equals. So I'm going to get my calculator. Doesn't even matter. Get my calculator, and I'll do 4 times 4 times 4. Nope, that's not it. So about 6 times 6 times 6. Because this means I have to do it 3 times, right? So 6 times 6 times 6. Whoa. 6 times 6 times 6. 216. There it is. So this negative stays here. The 3rd root of that is 6. So I have negative 6. Number 9. Negative 8 to the 2/3. Now when we remember exponents written like this, the denominator what goes here. And the negative stays with it because inside the parentheses, and then that's squared. So what times itself 3 times equals negative 8? I think it's negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So negative 2 squared. Negative 2 times negative 2 is 4. So we have 4. Okay. Graph the function to describe the domain and range. Domain is all x values. Range is all y values. All right, so x, y. So let's do the negative 2, negative 1, 0, 1, 2, and see where that gets us. So I'll plug a negative 2 into here. So I have 0.5, 0.5 to the negative 2. 0.5 to the negative 2 is 4. 4 times, so 0.5 to the negative 2 is 4 times 3. 4 times 3 is 12. Let me show you. Make some more space. I'll do this. So I did 3 times 0.5 to the negative 2. Well, 3 times, so 0.5 to the negative 2 is 4. So I get 12. That's how I got to 12. So let's do the negative 1. So 3 times 0.5 to the negative 1. 0.5 to the negative 1 is 2. So 3 times 2, so I get 6. 0, well, anything to the 0 exponent is 1, so it'd be 3 times 1, so that's 3. And then 1, so 0.5 to the 1 exponent just leaves it at 0.5. So 3 times 0.5 is 1.5. And then 0.5 squared would be 0.25, right? 0.5 squared, so to the 2 value is 0.25. And 0.25 times 3 is 0.75. Okay, so let's try and graph this. Negative 2, 12. Negative 1, 6. 0, 3, 2, 3. 1, 1.5. So 1 is a 2. So 1, 1.5. 2.75. So you can see I have, there we go. There's my graph. Now, for 11, there's my graph, my domain, which is my x values. Well, it goes on this way forever, right? So my x value goes on this way forever. And then this actually, if I go high enough, if I go far enough out, this will keep going on my x value. So it's actually for my domain, it's all real numbers. And then my range never quite touches 0. So, but it keeps going on up forever. So y is greater than 0, but it's not equal to because it never actually touches 0. Okay, good news for you guys. Don't worry about 12. Don't worry about 13. Go right into 14. These are kind of fun, I think. So, state the domain and range of the function. Evaluate the function when it's when x equals negative 2, negative 1, and 2. Okay. 15. So when x equals negative 2, let's see, which one of these gives us a negative 2? X is less than negative 1. So if we have a negative 2, if we plug a negative 2 in, this is the only place it works, and we're on a flat line. So it's 3. So when we have negative 2, our answer is 3. Let's check negative 1. Where is negative 1? There's a negative 1. It's greater than negative 1, so that doesn't work. Here's equal to negative 1. So negative x minus 4. So we have negative x, which is negative 1, plus 4. So we have, that becomes a positive. So we have 5. So when it's negative 1, our x value is going to be 5. And our last one is 2. So where do we have between, so x is between 1 and 4. So 2 is between 1 and 4. So our y is going to be negative. So it's going to be negative 2. So to solve these, you need to look for what parameters work for your number. And then once you find the correct parameters, you input it into that equation. This one doesn't have an x value, so if it works in here, then my answer is going to be 3. Now, here's something else I'd like to do. This one's 16, it says graph the function. So I'm going to let you graph this one. But to show you how to graph, I'm going to go ahead and graph number 15. So the first thing we learned when we were doing these piecewise functions is we learned to mark our boundaries. So 1 is a boundary. So there's 1. 4 is another boundary. Negative 1 is another boundary. 1, we already got 1. We already got negative 1. So those are our boundaries. Now we're going to draw our lines. So remember, I'm doing number 15 for this graph. I'm doing 15. You are going to graph 16 here, but I'm graphing 15 just to show you, remind you how to do piecewise. All right, so I have first one, y equals negative 2. So if I have y equals negative 2, that's a horizontal line. So I go to negative 2, and I draw my line. Now let's check the boundaries. It's only when x is greater than 1, so greater than or equal to 1. So that's a darkened in circle. It's going this way. And less than 4. So that's an open circle. So I erase everything that's outside of it. So there's my first piece. It's my first function right there. Okay, now I have negative 1 plus 4. So what I'm going to do for this one, this is right here. Y equals negative x plus 4. My slope is negative 1 over 1. It's negative 1. My y-intercept is 4. 1, 2, 3, 4. So there's my y-intercept, and then I go down 1 over 1, down 1 over 1. So there's my negative slope. Okay, there's my slope. Then I check my parameters. It's when x is greater than or equal to negative 1. So greater than or equal to negative 1 and less than 1. So open circle. So there's that piece, and that's this one. And now I have y equals 3. 1, 2, 3. So I have this line here. I'm guessing it doesn't go further. Let's check. When x is less than negative 1. Oh, here's negative 1. So it's an open circle. Let me include this. It goes this way. There you go. Now, let's say the domain, I forgot the domain and range of the functions. So here's my function. So my domain is my x values. So if I look on here, I see, oh, my x values, so I go negative forever, comes up and stops here at 4. So my domain is x is less than 4. Now I can check it here by looking, x is less than negative 1, okay. X is also in between negative 1 and 1, and x is between 1 and 4. So all of the numbers up to here. So x is less than 4. And then my range, if I look here, here I have y equals negative 2, because it equals this. But then there's this jump. Y doesn't equal 1, negative 1, 0, 1, 2. It equals 3. So it goes from 3 up to 5. So x is greater than or equal to 3, less than or equal to 5. Oops, sorry, that wasn't in the book or on the video. 3 is less than, x is greater than or equal to 3, but less than or equal to 5. So here's my 3, so it can be equal to 3, and then it can also be equal to 5. All right, so that's how you graph a piecewise function. Go ahead and graph 60 and see how you do. All right, the last two for today. Find the inverse of the function, then graph the function and its inverse. So for 17, if I want to do it mathematically, I can switch, don't forget, this is y equals this. So I can switch my y and my x, and I can say x equals negative 2y plus 4. Subtract 4 from both sides. I get x minus 4 is negative 2y. Divide by negative 2. So I get x divided by 2. So that's 1/2 x. So I have negative 1/2 x. Negative 4 divided by negative 2 is a positive 2. Plus 2 equals y. And just so that it's easier for me to read, I'm going to put the y over here and say y equals negative 1/2 x plus 2. So that's the inverse. And I could say my slope is negative 1/2. My y-intercept is 2. 1, 2. Negative 1/2. So down 1 over 2. Down 1 over 2. There's my line for my inverse. For my function, I start at 4. 1, 2, 3, 4. And then I have negative 2. Did I mess up here? Nope. So I have negative 2 over 1. So down 2 over 1. Down 2 over 1. Down 2 over 1. So what it looks like is this. So there's my regular line. That's this one. And then my inverse is this one. That's my inverse. And if you remember, it's always off of y equals x. So this point is reflected in this point is reflected in this point. Now, what if you didn't want to do this fancy pants stuff? Well, you could do a table. So let's plug in 0. Negative 2 times 0, 0 plus 4. So if I plugged in a 0, I would get 4. What about negative 1? Negative 2 times negative 1 is 2. 2 plus 4, that's 6. How about a 1? Negative 2 times 1 is negative 2. Negative 2 plus 4 is 2. So that's enough to plot. So 0, 4, there's 1 point. Negative 1, 6. Negative 1, 6, there's another point. 1, 2, 1, 2, there's another point. So I've got enough points to graph my function. And then my inverse is just I reverse these, right? My x's become my y's become my x. So now I have 4, 0. I have 6, negative 1. I have 2, 1. So I have 1, 2, 3, 4, 0. I have 6, negative 1, which is off the chart. And then I have 2, 1. Perfect. Then I could go, I could throw a 1 in there. So anyways, so that's how you do it if you want to make a table. That's how you do it if you want to do it with arithmetic. You don't have to do both. Just pick one. All right. Let's do this function if x is greater than 0. So let's deal with that in a second. Let's just see this one. So this one, I'm just going to go straight to the table. So I'm going to do my original function like this. I'm going to say x squared. Let's take a negative 1. So negative 1 times negative 1 is 1, plus 4 is 5. 0. 0 squared. Oh, wait. I can't do negative 1 because this doesn't include negative 1s. So 0, 1, 2, 3. So 0 times 0 is 0, plus 4 is 4. 1 times 1 is 1, plus 4, that's 5. 2 times 2 is 4, plus 4, that's 8. 3 squared is 9, plus 4 is 13. 0, 4. 0, 4. 1, 5. 1, 5. 2, 8. 2, 4, 5, 6, 7, 8. 2, 8. So it's kind of going like this. So there it is. Now if I do the inverse, I have 4, 0, 5, 1, 8, 2, 13, 3. 1, 2, 3, 4, 0, 5, 1, 8, 6, 4, 5, 6, 7, 8, 2, and then 13, 3. So this one is going like this. And look at that. That's kind of cool. Okay. Sure enough, this one is reflected across here. This one's reflected across here. I don't know if you remember the fold your paper thing, but if I were to fold this straight over, they would sit right on top of each other. Pretty cool. There's your answer 19. All right, your homework is to do 1 through 20. Please call or Zoom or anything if you have any questions. Thank you very much. Talk to you soon.